Although we may not notice its presence all around us, nitrogen is an element that's essential to all life on Earth. And nitrogen gas accounts for almost 80% of our planet's atmosphere. But what would happen if it were to disappear? This is Unveiled, and today we're answering the extraordinary question, what if Earth ran out of nitrogen?
Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one and ring the bell for more fascinating content?
When it comes to nitrogen, it may be everywhere, but it's not always usable for us. The abundant atmospheric nitrogen is an inert diatomic form, for example, and it requires conversion into usable compounds like ammonia to support most living things. Its other crucial purpose, though, is more direct, because nitrogen is vital in maintaining the balance of our atmosphere, the pressure, reactivity, and composition of this place we call home. And without nitrogen to flesh out the air, the conditions down here on Earth would be very different indeed. So in today's video, we're going to consider two scenarios. One where all nitrogen is suddenly lost, and another where it more gradually becomes unavailable to us. Firstly, the sudden loss. And here we have instant chaos. Take nitrogen away in a moment, and the Earth's atmospheric pressure abruptly drops by 80%. A decrease of this magnitude would constitute what's known as explosive decompression. Severe explosive decompression. In human beings, it would show itself in a number of ways. Via severe barotraumas and all-encompassing tissue damage, for example. Via our eardrums blowing out, our sinuses popping, and our lungs potentially collapsing as the gas within reacts. Our blood vessels could follow, hemorrhaging due to gas embolisms, and our bodies could swell. Without pressurized suits and supplemental oxygen, we may enter a comatose state within minutes. We know that for the likes of pilots and deep-sea divers, depressurization is a fairly common experience, but the world as a whole won't have seen anything like this. Billions of people and animals would certainly die. There are some exceptions when it comes to surviving extreme decompression, with various sea creatures being able to withstand rapid and large pressure changes, a prime biological advantage in this situation, but it still wouldn't mean they'd be safe, because their time would be cut short by the destruction of their ocean habitat instead. Strip away the nitrogen, deplete the atmosphere so dramatically, and all bodies of water would boil and evaporate, once again rewriting the rules of planet Earth, which is bad news for anything trying to survive under the waves. And finally, what about airborne creatures? Well, they'd be doomed as well, because for objects to be in flight under usual conditions, the surrounding air provides enough lift to counteract gravity. But now, with the atmosphere so suddenly and harshly decompressing, the surrounding air is a totally different prospect, and everything in it, from birds to planes, would invariably plummet to the ground. And it's not as though the world would get any better even after the initial chaos either. For example, in the now majority oxygen atmosphere, combustibility would skyrocket, leaving the Earth ablaze. Plus, our planet may find itself more vulnerable than ever to cosmic radiation from space, meaning that direct and mostly unfiltered sunlight would gradually burn everything to a crisp. Again, humans might find a way to survive if they just so happened to be in pressurized suits when this obscure disaster struck, and they found a way to stay in them indefinitely. But the odds are extremely low. Thankfully, today's second scenario isn't quite so devastating. Or at least it's not quite so devastating quite so quickly. Now we consider a situation in which nitrogen gradually falls and becomes unavailable. What would happen then? Here, the nitrogen cycle is key. Aptly named, this is what cycles nitrogen through the environment via a number of processes, including fixation, which is what nitrogen gas goes through as it converts from simple molecules in the air into compounds in soil and water. Much of it is orchestrated by bacteria, with the term biological nitrogen fixation, or BNF, referring to how bacteria convert nitrogen into ammonia and pass it around the world. It can also, on a smaller scale, occur in other ways though, such as during lightning storms. Here, as lightning strikes, the intense heat triggers the formation of nitric oxide in the air, which is then deposited into and used by ecosystems all across the planet. But then there's also human-led nitrogen fixation, which takes place during the burning of fossil fuels and the production of fertilizers, for example. We know that these activities have many negative follow-on effects for our world, and they play a key role in the balance of nitrogen today. with some estimates suggesting that more than half of all nitrogen fixation, more than half of the entire nitrogen cycle, now comes from human activity. So what happens if all of that slows down? At first, it might well prove to be beneficial for us and the planet, as currently we have an excess of fixed nitrogen on Earth. There are too many converted nitrogen compounds in the environment, and the so-called nitrogen scraps produced by agriculture and other human activities are thought of as ticking time bombs, because they're just waiting to be turned into nitrous oxide, a dangerous greenhouse gas that traps heat, accelerates global warming, depletes the ozone layer, and opens the door to more and more ultraviolet radiation, none of which is good news for the future of Earth. So really, we could do with losing a little bit of nitrogen here and there. But still, were nitrogen to become less and less available to us, then we'd need to make some serious changes. More than half of the world's population is dependent on synthetic nitrogen fertilizers to grow crops, for example. Most of the rest of the other half of the population uses crops that have naturally occurring symbiotic relationships with nitrogen-fixing bacteria. Both options would be impossible were nitrogen to disappear, though. And remember, while all of this is happening, human beings would still be having to adjust to decreasing air pressure, increasing combustibility, and all the other facets of a sudden change, just on a slower timescale. Only now, we'd also struggle to grow anything in the meantime. The process may not be so violent as that which we'd see with an instant change, but the results are much the same. Take nitrogen away completely, even very slowly, and eventually everything dies. The growth of life on Earth plateaus and declines as nitrogen sources pass through bacteria, plants, animals, and humans through the environment to ultimately become unreachable again in the atmosphere. The nitrogen cycle destroyed. Thankfully, we're not at risk of this particular hypothetical scenario happening in the real world. Nitrogen isn't going anywhere. And in fact, because of that excess of nitrogen mentioned earlier, we are actively trying to reduce nitrogen in the 21st century. Researchers are working to lessen the amount of it in water and soil, and thanks to the use of denitrifying bacteria across various experiments and initiatives, the fixed nitrogen levels on Earth are decreasing as intended. But just as you can have too much of a good thing, in this case you can also have too little of it as well. In general, the existence of nitrogen is crucial to the existence of us and the existence of Earth as it is. We know that the conditions of our home world are finely balanced in just such a way to allow for life. Currently, excess nitrogen is threatening that balance. But while we are trying to control the nitrogen cycle better than we have done in the past, if it were to ever just break down completely, and if the element were to somehow evaporate, then we'd have some other major issues to contend with. If it happened suddenly, then we'd all be dead or extremely ill before most of us could even realize what in the name of science was going on. If it happened gradually, then no doubt we'd try to counteract the situation, perhaps by concocting a wholly artificial nitrogen cycle and spreading it back around the planet, ensuring the global environment remains topped up to precisely the required levels. If we could one day find a way to produce more nitrogen without pollution, then who wouldn't want that? That way, we'd have what we need without ever having too much. But until that day, that's what would happen if Earth ran out of nitrogen.
What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.